So, you said the original way was what was it? For every ton of steel, it was 600 kilos of coal, or coking coal.
That used to be, but they brought that down to around 500, right?
Right.
It's not at that because there's another.
Coking coal's the volatile stuff.
Coking coal is what's left after you create the coke from coal.
Right.
And the reduction from coal to coke, there's about 1.4 tonnes of coal for every tonne of coke.
Right.
Yeah.
And the other 400 kilos that goes off is all that gas shit.
It goes off into the gas and tar, all volatiles, chlorine, sulphur, all that
shit. It was the green shit that you were talking
which they take out. So there's always a chemical works attached to a coking plant.
Right.
Yeah. That takes it all off, and they try to clean the cog. Now, cog basically is 90% hydrogen.
Right.
So cog should be almost hydrogen. It's what we used to call town gas. So before we had North Sea gas, we used to have coking plants all over the UK. So they produce coke, which people used in fires.
Yeah.
And town gas.
Right. And the town gas is all the shit that comes off, which is all of the...
Well, yeah, after it's been processed.
Into
tar.
Alright, so they take the tar away from the gas.
The tar and the chlorines and things like that.
All that shit comes off, that's the tar.
Yeah.
And then what's left is the town gas.
Yeah, well...
Or the coke.
We used to have... I'm trying to think of there used to be a name for it. It'll come to me later. But they used to store the crap in bags.
Yeah.
Right? The cog is used either for town gas or it's then used in the steel making process. So they use the energy in cog is around about 17, 18 megajoules per cubic metre.
And that's all hydrogen?
Well, that's more or less hydrogen.
Oh.
I mean, natural gas is around 35, so it's about half natural gas, because it's just the hydrogen part of it, it's not all carbon side of it.
What's this argument about the new mine that they're on about, where they're on about digging down to get to the coking coal, though? Is that just high... It's not actually coking coal, it's just actually high...
No, coking coal is high volatile coal, which is ideal for making coke.
Right, okay.
Yeah?
So you have to process it before you get...
So coke is used in the blast furnace
to
reduce the Fe, the iron ore, down. Yeah? Okay, so that was around 500, so that's about half a tonne of coke for every tonne of steel or iron produced.
Right. And then how much coke do you get out of the coking coal in terms of proportions?
Well, the best is around about 1.4 tonnes of coal for every tonne of coke produced.
And the rest is all that shit that's given off.
Yeah. So don't forget, you've got to heat the coal, right? So that's why they use some of the cog, the coal, the gas, the recycle to heat, or they use other gases that are from the processes like blast furnace gas or steel making gas. But they're very low volatile, so they're only around 3.5 megajoules per cubic metre.
So what's the reaction that takes the reduction process of the FeO with the coke? What is it? Is it a hydrogen that's reducing it?
Well, it's the coke's the carbon, yeah.
Yeah.
So
you need carbon to actually reduce it.
Well, coke is the reducer.
Right.
Yeah.
And the carbon takes the oxygen.
So what if you look at the carbon equivalent diagram, what you'll see is temperature, and you'll see where you get the reaction
Yeah.
So basically, you reduce FeO, and there's different reactions within the blast furnace at different temperatures. Right? So the higher the lower the temperature, the lower the level in the blast furnace, the higher the temperature.
Right.
So that's where you do the final reduction.
Yeah.
So what have you got to provide? So you've got to provide heat.
Yeah.
Yeah. So what they've started doing is that they start injecting now coal, pulverised coal. It's called PCI. Yeah.
Yeah.
Pulverised coal injection into the bottom of the blast furnace.
Right.
And in doing that way, you take away the coke inefficiency, from coal to coke.
Yeah.
But you can only go so far with that. But that's now reduced the amount of coke being put into the blast furnace.
Right.
You have to mix coke,
Yeah.
lime,
Yeah.
and iron ore,
Yeah.
sintered iron ore, it's like a cake,
Yeah.
into the top of the blast furnace. So they're all mixed.
Yeah.
So when you fire the heat through,
Yeah.
that's why you get the reactions. Yeah. So the lime sucks out things like sulfur or any other non-volatile type materials, and that produces the slag.
Right.
Right. The iron itself then drips out. Once it's fully reduced, it then drips out and goes into the bottom of the furnace. So basically, you've got a big pot with iron building up on the bottom, and on the top of it, you've got all the residual shit.
Yeah.
Slag.
So
effectively.
That's basically contains the oxygen from the iron ore then?
No. The oxygen,
Yeah.
after the reaction,
Yeah.
goes into gas form as CO.
CO, right.
Yeah?
Oh, right, so the coke provides the carbon to make the CO out.
Right. So what's also now being produced
Yeah.
is something like about 1,800 cubic metres for every tonne of steel of
Right.
blast furnace gas.
Right.
BFG. But it's CO. So the CO reaction, when you burn it, is only around 3.5 megajoules per cubic metre. Right? But they suck that off. That comes off. Yeah.
Yeah.
And then they'll use that. Might even use that to heat the coke oven. Yeah.
Right.
Oh, because if you go past any of the metallurgicals, you'll see big gas holders. Yeah.
Yeah.
And they're there just to maintain the pressure in the system. The gas either has to be flared or used. So they'll use it in the other process. They'll use it for reheating, reheat furnaces, or heating ladles, or they'll do it for all sorts of stuff.
So this argument about replacing the coke in steel making with hydrogen.
Well, for me, it's false, because the amount of hydrogen you'd need is unbelievable. And how do you make the hydrogen? It's okay for small bits, yeah?
Yeah.
It's all okay for small bits. But the real issue in the steelworks is the amount of oxygen that they have to use as well for reducing the iron, the carbon in the iron ore. Because in the iron itself, when it comes out of the blast furnace, there's up to like 3%, 3.5%, or 4% of carbon in the iron.
Right.
Which is no good for steel mix, and you need to get less than 1% carbon. So what you have to do, you have another process, i.e. the steel making,
Yeah.
which in the integrated plants now they inject masses of oxygen to burn off the carbon. which also produces carbon gas, CO. Yeah? You can't use
It's
that.
just integral to the process then.
Yeah, well, that's why it's called an integrated works.
Yeah.
Because the whole process is. I've got a couple of. Well, I've done them because I've done them for other. I can give you. Just Sankey diagrams which show the whole process.
Yeah, that'd be great. Could you talk about scale in terms of, because you spoke briefly about Scunthorpe and Port Talbot and what they produce.
Yeah.
But then talk about the big producers like China and whatever, and in terms of give reference to scale.
Well, what it is today, I'm not 100% on, but I can give you what it was a few years ago.
Yeah, that's enough.
There's two ways of making steel. You've got from first principles, which is basically reducing the iron ore,
which is the blast furnace methodology.
There's blast furnaces, and then there's an alternative blast furnace which is called direct reduction. We can go into that as well if you want, but that has to use a lot of gas.
Is that what the argument for the hydrogen thing would be for?
Well, they use natural gas, and it's the hydrogen in the natural gas, isn't it?
Yeah. So it's
still
got fossil fuel.
What you'll find is where most of these DRI plants are, and they are quite extensive now, are in areas where there's natural gas.
Right.
Because you've got to look at the future. We either use the coal or use natural gas. So it's cheaper to use direct reduction.
Yeah.
But there's another process which is a problem with direct reduction, which is how you make the pellets, because you've got to make the iron ore pellets. You've got to have very high iron content ore. Most ores now are around about 25 to 30% iron. Yeah?
Yeah.
So you have to concentrate it. So you have to grind all the ores up. Right? So that's another added process.
Yeah.
Which costs. You've got big ball mills that grind up the, and then you have to concentrate the ore. Because to produce the DRI that you put in the DRI has got to be over 67% iron content.
Yeah, so that's a lot of energy that comes into.
So this, whichever way you look at it, it's a lot of energy.
Yeah.
Yeah. Now, how much? Okay. Some of the plants I worked at were like the Eastern European plants. Don't forget, I'm only talking about at the moment metallurgical. This is the.
Yeah. Of course.
We're not into the other.
We're not into arc furnaces.
Not into arc furnaces. We're into the metallurgical, which is a 60-40 ratio. So it used to be 60-40 ratio. So 60% is metallurgical route, 40% electric arc route.
Right. But
with DRI now, it's more like 50-50 because you get DRI, and then you go electric.
Right. And electric is just recycling, isn't it? You're reprocessing.
Unless you're doing DRI,
Unless you're doing DRI.
The pure EFs were recycled.
So this is why your argument about the hydrogen thing, it would have to be a DRI process, and the amount of hydrogen you would need would be massive amounts.
Yeah, the different technology. I looked at different technologies.
Yeah.
For this, yeah. There's one I like very much. It's called Hismelt. Yeah.
Right.
But that.
So talk about scale then, just to wrap this up.
Right. So scale.
Yeah.
At the moment, well, years ago it used to be around 800 to 900 million tonnes per year were produced worldwide.
Right.
Yeah. China produces more than that now. So we're in around 1.5 billion tons of steel is produced in all the processes a year. Yeah. So let's say there's around 700 million or 600 to 700 million tons of metallurgical steel produced.
Yeah.
Right. So go back to the old.
Oh yeah, I get where you're coming from there. Because it's
just
60, 40, 50.
Just think about the amount of coal that has to be used.
And the Chinese produce of that in terms of proportion.
The Chinese are doing at least around 50% of the steel. Yeah.
What about the Europeans?
Europe's around about 100 million tons. America's around 100 million tons.
Right.
Japan's around about Japan, Korea, India does quite a bit, but they're getting bigger and bigger. It all comes down to the amount of kilograms of steel per capita.
Right.
So the best way to look at it is you'll find a map where you say what's the steel usage per capita for given countries. Now, developing countries, they'll all be over 150, more like 200 kilograms per capita. Maybe as high as 450, like in America, or 500. That's every bit of steel that's used per capita.
Per head.
Per head. So there's 300 million people in America.
Yeah.
Yeah. So in the UK, it used to be around 15 million tons we used.
Yeah.
So you divide that by
Oh, right.
the number of people, and that gives you how many kilograms. You can work it out on building sites as well. So if you look at typical building site, just normal concrete, it's around about 150 kilograms per tonne of concrete.
So of the proportions then, China are doing 50%, Europe seems to be doing about 10%, if that?
Yeah, China is up and down. It all It all depends how the.
So if Europe's doing 10%, the US is doing about 10%.
Yeah.
I suppose the remaining 30% is.
Some countries they're down to like 20 and 30 kilograms.
Japan's about 10%. Then it's the remaining, like the chart.
What you've got to look at is the ton of steel per capita per year. Yeah, and the small underdeveloped countries are only like anywhere between 10 and 30 kilograms per capita.
Per capita.
Yeah.
Right. So it's down to how much you're producing per person.
Yeah. But if you look like what Dubai did when Dubai was going, theirs will have gone up. Fantastic. Yeah. But for a short period of time. There's lots of statistics on it. They're all over the place.
And where are in terms of the direct reduction processes and in terms of the metallurgical processes?
Yeah.
The majority of them you would say is Chinese.
Well, I wouldn't say no. Chinese have gone more for because they haven't got natural gas. So that most of their development was in electric arc but mostly in metallurgical steel. So they've got plants that are producing one plant producing up to 30 to 50 million tons. So you have massive blast furnaces. Some of these blast furnaces, you're talking 7 to 10,000 tons per blast furnace per day.
That's like 3 to 5% of the global production.
Yeah. They're absolutely giant. And all this has happened since I went to a conference in Singapore in '98, right? So how many years? That's 23 years ago. Steel, the world. It was the World Steel Conference in Singapore, and at that time there was 800 million tons per annum being worldwide, right? And China were number 3, and most of their This will be a parcel.
Finish that.
Right. Most of their steel making, like Manchester Steel and Bidston, went to China. Yeah.
Yeah.
What they used to do was buy old plants and
ship everything over.
Ship over there, reimplant them, start them up to get their steel industry going. And then at this conference, they said they'd be going up to 180 million tonnes by 2005. Right? Now I know they're up to 700. I know over 800 million tonnes of capacity. They've just gone. So all the steel makers, all the steel suppliers, oh, this is fantastic. They all started pumping all their products. You couldn't. The prices went up. Anybody else trying to do anything, because everything was going into China, and China were building their manufacturing base up to produce. Because if you sold anything in China, 85% of it had to be built in China. So all the drawings, all the designs, everything went into China.
Oh my God.
So now, where does all the cheap steel manufacturing companies come from? China. And
we give them all the knowledge.
You've given them all the knowledge. Now, some of the companies were quite cute and tried to keep, but the Chinese, and the same things happened with aerospace, everything, cars, everything. Where did a lot of the steel, the car producing stuff go to from the UK? China. Where did all the motorbike stuff go? Well, a lot of it went to India. Yeah. It's just, then this is politicians and people just not. Yeah. What should have happened, if they'd had the minds around it, is, okay, China, oh, we want this, fine. Okay then, but we make it here and we ship it to you. And the Chinese say, no. You should have hung off. But it was all to do with money. Anyway, back to the steel. You want to talk about steel making. So, they've reduced the amount of coke they can use in the steel making process by using direct carbon injection.
Mm-hmm.
But you still have to use something in the region of around 600 to 700 kilograms of carbon going into the blast furnace to produce a ton of steel. Now I know you've got, because I've sent you. There's the European Environmental
Yeah, the European Environmental Agency thing.
Environmental Agency. They do, one of their articles is on steel making. You'll see everything in there on that. Because to make a ton of steel, the most efficient in the metallurgical process is around 18 gigajoules, yeah, per ton. Now, a lot of the inefficient ones, like Eastern Europe, are in the 30, 25. The best, in electric arc, the best is around 550 this is per finished goods.
Yeah.
Kilowatt hours per ton.
That's a lot.
It's actually megajoules, not gigajoules.
Megawatt hours.
Megajoules.
All right. Megajoules. Oh, right. Okay. So then you'd work out.
Yeah.
Yeah.
Because what you've got to put into it is all the things like transportation. You put everything into it. But then you think about the amount of lime you use, yeah? how much alloys you use.
Yeah. So the crazy thing about this mine in Cumbria, where's that coal going to be? Where's that coking coal?
Well,
going
that
to be
coking coal should be sent to either Scunthorpe or to. But if they're trying to get it out and send it to China, they're shooting themselves in the foot. But actually, the next to Port Talbot, there's a big environmental area, and underneath there, that's full of coking coal. But they can't get at it, because it's not allowed. Yeah.
It just gets sold to China, wouldn't it?
Yeah.
And I've heard them say that directly on the radio. That no, it's really for the international market. And in actual fact, you think about it, it's going to go to China.
Most of it's going to go to China if it's coking coal, because there's very few now. There's a few blast furnaces in. I think probably in the UK there's only about 3 blast furnaces now.
How many was there in the day?
Oh, dozens. I mean, because they're all small, you think.
Yeah.
So now they make these massive ones. The amount of steel that comes out of iron that comes out of them, it's, as I said, up to 10,000 tons, 12,000 tons.
And where are the main industrial bases in the UK?
British Steel, when it was formed, there was something in the region of about 30 or 40 steel companies in the UK. There were Birmingham, Manchester, Glasgow, Scunthorpe, Teesside. There's another one in the east.
Port Talbot, all that one.
Lanwern, Port Talbot, Cardiff.
Yeah.
But a lot of them were private companies. And then when they did the nationalisation in the 60s, the idea was what they called the Big Five. So the idea was to build these new integrated works, and the first almost worldwide integrated works was done at Port Talbot. And what that was to use was blast furnaces, which had been there before, and convert from what was open earth steel making to basic oxygen steel making, so that's BOF or BOS. And the idea was to have 5 big plants, all producing around 3 million tonnes, 3 to 5 million tonnes of steel per year. So the market in the UK was around it's still around 15 million tonnes, but we only produce less than half of that. The rest of it we have to import because we got rid of our steel industry. Right? So,
which was of our making.
Which was really, the Brits and the Americans and the Germans are the real ones who did the steel making. So the 5 big plants were supposedly Port Talbot, Lanwern, and Scunthorpe, Teesside, and there was going to be one in Scotland. Right? So there's another story about Scotland to do with DRI, which I'll come to in a sec. So fairly quickly after British Steel was formed, what they then did, they all the smaller plants like Earlham, the 2 plants in Scunthorpe, a plant up in Teesside.
And how much did Earlham produce?
About 1 million tonnes.
Oh, okay. Well, go on a little bit.
Yeah, but that was it. 5 blast furnaces and 1 million tonnes, because the small blast furnaces, furnaces, It used to take 15 hours to produce
and Grandad would work on one of them then, yeah?
He worked on the steel plant, yeah. Well, he worked as a shift engineer. So that's why all these small plants were closed. Some were kept open but not producing steel. They started producing things like pipes or process plants and things like that. So Llanelli is an example where they did the tin plate.
Right, yeah.
So fairly soon they decided, we don't really need 5, we only need 4. But then a political decision came in. So they split the 4th one into 2. Half of it they put in Llanwern and the other half they put up at Ravenscraig in Scotland,
right.
Wishaw. 2 identical plants that were supposed to be together.
Right.
Yeah? So these had smaller BOFs, 150 tonners. The ones in Scunthorpe and in Teesside and in, certainly Port Talbot, they were the biggest for blast furnace, BOFs, like 320 tons, 300 tons of steel they make every half hour, if they wanted, yeah? That's why it could go up to 5 million tons, and these others were like 2 million tons, 3 million tons. Right? And then there's all the other processes around it that you have to do. And of course what they did, so not longer after they got Ravenscraig, gone. Llanwern, gone.
How long were they active for then?
10, 15 years, something like that, 15, 20 max.
Did they even get the money back on them?
No, well, it was government money, wasn't it? It was national state. That's why it was costing at one point something like 1 to 2 million. They were losing 1 to 2 million pounds a day, or maybe even more than that. I mean, if they shut a blast furnace down now, you're talking at least £1 million a day. At least. Yeah. Even the electric arc, we were losing 20,000 a day if we shut down, just on losses. When I started, there was 170,000 people working in the steel industry at this time. Yeah. Now there's something like 20 at the most. Remember what my job was?
Yeah.
Automating, getting rid of the zero inflation on people and salaries and so on. Everything was cut. More efficient. Now places like China and all these places, they
ramp it up.
They don't. I mean, they have thousands. You know, even in India, you've seen them. The women used to carry the coal from the train.
Yeah, it's a much more complicated process, because when you think about it, you're not just having the industry. Yeah, it might be costing you money, but there are benefits from that, such as security.
No, yes. Well,
and
it's why. I mean, at one point, why did we had the biggest steel industry? Why? Because we made all the ships.
Yeah, it supports everything else that you make money on.
Why was steel making up in
It's
Glasgow, Scotland? Because that's where they made the ships. Where was the other place that made the ships? Teesside. So that's where the big industry was.
Yeah, because it supports all the other industries that make money.
It supported everything.
That make money.
Why was steel at Scunthorpe, which was a peculiar place? Well, the reason was that the docks at Grimsby and places like that weren't that far away, and Lincolnshire was built on iron ore.
Yeah. So in our place where we're having to buy in steel products and the price is going up, that's partly because We just got rid of our own industry and sacked
Well, part of it, but it's the cost of producing the steel.
Yeah.
Right? So the beauty about producing steel from iron ore is that you've not got the crap that can go into things like copper.
Yeah.
Right? Copper gets into steel, you can't get rid of it. The only way you can get it out is by dilution.
And that happens in arc furnaces, yeah.
And the problem with arc furnaces, all the shit goes in from car scrap and things like that, and so you have to bring in iron. We used to have to add iron pellets.
Yeah.
To reduce the amount of copper.
Which comes from the blast furnace anyway.
Which comes from the blast furnace, because you bring pig iron in. Okay? So depending on what grade of steel you're making. So why did arc furnaces came in? Well, arc furnaces have been here since the early 20s, but very few people used them. In the 70s, two people, one in the States and one in Germany. The one in Germany was a guy named Willy Korf. They had this idea of producing localised arc furnaces to produce rebar, basically. You know, because we were using steel and rebar. Remember what I said about every average ton per ton of cement is around 150 kilograms of steel. So you want cheap steel. So rebar became cheap steel. So they produced basically a remelt. So you got local scrap coming in, an arc furnace, and a rolling mill that produced, or caster to produce this continuous casting new technology that came out, and a rolling mill. Whereas before, metallurgy, all the metallurgical process, including the blast furnace, then a steel making process, then an ingots, then it cut out, it reduced the cost by 70%.
I'm just thinking again back to it all comes down to the amount of energy you use per kilo of steel, isn't it? Ultimately.
Yeah. So per capita.
Per capita, yeah.
Yeah. So what you ended up with now is all these small little arc furnaces that come in are all competing with each other. So we've got one furnace, I make two furnaces, so they got bigger, because they originally set them up to produce around about 250,000 tonnes. Yeah. So think about it. One steelworks producing 250,000 tonnes. 40% of let's say 20 million tonnes. So we're 8 million tonnes of electric arc making. So that's 8 times 4. So theoretically you could have 32 of these electric arc plants, and they started popping up all over the show. But inefficient 250, so they want to be 500, and then the ultimate they want to be 1 million tonnes, right?
Yeah.
So what you ended up with, the first big one was Sherness, and that was done from the guy in the Americas. They built one in the UK. So Willy Korf, so he built one in the UK. What was that? Manchester Steel. So people in Bidston, which was British reinforced concrete. Yeah, they want their own steel supply. Yeah. So they built Bidston Steel, which we amalgamated with Manchester Steel. So British Steel thought, oh well, they're all starting to do this, so they built plants in Sheffield, Stocksbridge, and places like that. And put GKN, another big, we can make nails out of this and wire. So they built Cardiff, yeah, and there was Peyton Shaft, another one. But now there was two the two biggest arc furnace companies was Manchester Steel and Sherness Steel, and were fighting against each other. And GKN came and had an agreement with British Steel, because British Steel used to produce all these long products, cheap. Oh, we want to get rid of that business because we're into big steel. All we're interested in is big coils for making buildings and cars and things like that. Big beams. So they sold the process. They amalgamated with GKN and they tried to rationalise the long product side into two. One is engineering steels. So engineering steels was started, and the other one was the reinforcing steels and wire products. So Allied Steel and Wire was formed, and the engineering side, which was in Sheffield, they looked after the things that goes into machine tools and landing gear, ropes, that type of thing. So what happened was, there's too many electric arc furnaces. So first of all, Allied, which at this point did not have Cardiff, it was being built.
Right.
Tried to buy out Sherness. No, the Americans wouldn't have it. So Sherness tried to buy out Manchester. What should have happened was Sherness and Manchester got together and knackered Cardiff. So Cardiff came out. Who owned Manchester? Norwegians. Weren't interested in steel. No, we want to get out of steel. They had a plant in Oslo, Christiana speaker and wanted out. Allied wanted, so they bought out Manchester Steel and closed it, which was BREXIT Steel. Who did they sell it to? Chinese. Right?
This is the Americans.
No, this is GKN.
GKN.
Yeah. Who, because they built this new steelworks and they were inefficient. They didn't have, because GKN had their own steelworks before, but it was a metallurgical steelworks. They knew nothing about the new electric arc and continuous casting.
They just give the knowledge away.
So they bought. Actually, the plants were built by Concast. Our plants were built by Korf, which was Willy Korf, German.
Yeah.
And Sherness was built by the Americans again. The arc furnace technology in these three plants were all by a British company called Burlek, who actually went out of business because of GKN. Because there was a problem with the wind stripes. There were electrical wind stripes, which we had problems with, but we sorted it. But they took them to court and get out of this. So the technology then went from arc furnace technology went to people like DMAG and German companies, yeah. And then Danieli came in. So Danieli built Bidston as well. Danieli is the Italian company, and they're probably one of the leaders. SMS, DMAG.
Hence the death of the UK steel.
Well, not only the death of the UK steel, but the death of the UK steel manufacturing companies. And that's why I ended up in Sherness. Because what I was doing here,
Yeah.
the personnel guys had moved, who knew me, had moved down.
That's why we.
And they were looking for somebody who was doing this automation. It wasn't the engineers who were doing it, it was the financial company, the finance department. So that's why I ended up there. They tried to poach me at the time and I wouldn't go. So that's why I ended up in Sherness.
Who tried to poach you?
Allied wanted me to go.
Cardiff.
And the decision was your mother's.
Oh.
So I was ready, because this job was, at the time, was a better job than that. As it turns out, that was all right. And your mum had already made the decision to move because I had another offer, New Zealand.
Oh.
But that was like, everybody was against that.
Sounds like you would have wanted that though.
Yeah, I wanted that. Because I said to your mother, I said, look, it's either Sherness or New Zealand. Take a pick. Well, I can't get a job round here. And I always remember your Nana Taylor and all this. Why can't you get a job round here, Well, I was on a high because I was going into what I wanted to do. So that's how and why we ended up in Sherness. And then, of course, Scunthorpe, the rod mill, which were owned by Alan, wanted to update their rolling mill.
Yeah.
And it was that rolling mill, that closed Earlham mill, that put me dead out of work. And our chief engineer at Manchester was the project engineer who did Scunthorpe Rod Mill. So I knew all. I knew the mill, yeah. So they offered me a nice job. So that's why I ended up in Scunthorpe.
That must have been an interesting conversation between you and Grandad then, when that was going on.
Well, Grandad wouldn't go to Scunthorpe. He was offered a job at Scunthorpe.
No, but the fact that you went there.
Oh, he was past it then.
Right.
He was past it then.
I suppose he'd been retired for.
No, he wasn't retired when we first went there, I don't think. Might have been. But he went to one of the plants, then that became part of the Allied group. He went to Monk's Hall in Warrington, because that's where all the wire drawers were.
Right, okay.
Another process to explain. Oh, anyway, of course, what then happened? Manchester went to China. Bidson went to China, and all these other plants closed down. And then Sheerness went to the wall. Allied took it over, closed that, and then you know what happened with Allied.
Yeah. Allied went bust, didn't they?
They went bust, yeah.
And they took all. Was that the one where they took all the pensions?
Yeah.
Yeah.
And at the time, there's one other plant which no one ever talks about, which is in Newport. It's called Alpha Steel, but that was a tax haven owned by Greeks, and people would only go there to work if they couldn't get a job, because it used to open and close. British Steel closed it. It had actually in its day some of the best stuff, because they bought, just to get rid of the tax, the money.
Yeah.
Slab casters. This is before British Steel had slab casters, and British Steel bought the they bought the market to close the market. to close the plant, and then took some of the casters which they used at Llanwern. Continuous casting at Port Llanwern and Port Talbot didn't happen until after Manchester Steel closed. But I went to Port Talbot and they had all this ball, we make all this continuous casting, all this. When I was acting as a consultant, and I'd been in it, I had more experience than anybody in Port Talbot on continuous casting, and I was just an electrical engineer. And it's a disaster port because they just don't look after the maintenance on the plant. It's falling to pieces. Because it's big steel. We are marvellous and big steel. But it's gone. Oh, it's going to go. Port Talbot go.
How long do you reckon they've got left?
Well, it could have gone now. I mean, it's only Tata saved them because Tata wanted into Europe. Of course, what they didn't really want Port Talbot. What they wanted is Hoogevens in Holland, because that was Chorus was British Steel amalgamated.
So, will someone done a deal with them to?
Oh, the government. They keep pumping money into it. Scunthorpe's almost gone 2 or 3 times. But we need a steel industry. No? And now that Brexit's happened, a guy took over, another guy took over from Tata, Scunthorpe, and they called it British Steel. But that's in trouble again. So it's all been, once the Labour government gets in, they'll have to feed money into it.
Yeah.
Because the impact in the air is be so.
Oh, just.
Yeah. But they're nothing now to what they used to be. Or it was at one time. The real moneymaker in Scunthorpe is the rod mill. That's what I used to work at. Don't forget what that goes into.
Oh yeah.
Yeah, fasteners, bedding and seating, car tyres, ropes, nails, all your stuff in your car, car industry. All your screws. Because most of these now that we're getting in the UK, are not coming from here, they're coming from China.
Yeah.
But all used to be made in the UK. It's what GKN did. It's all fasteners. It's what GKN came from. That's why they wanted their own steel supply. Right? So then it became, you've got, why are we, this is not our core business. So that 30 years ago, 20 years and 30 years ago, it's all about, the only business we should be in is our core business. Everything else can be supplies. And what's happening now? It's going the other way. Why is Tesla so successful?
Because he produces everything.
Because he's fully integrated all the way.
Fully integrated, yeah.
Huh? Yeah. It's all short-term thinking. None of them were thinking in the longer term. And you can't tell them. Yeah. No. Because that's what I was doing, and that's why I said in the end I refused. I said no, it's not right what we're doing.
Yeah.
Yeah.
Because you're wrecking everything, aren't you?
Yeah.
You're effectively decommissioning the entire industry.
And that's what wrecked Allied,
yeah. Because
he said, well, at one point he said, we are not a steel making company, we are a engineering company. And so he wanted to sell everything up. Yeah. But then spent a fortune trying to build up this design and engineering company, which was fighting against existing design and engineering company. When I moved to Scunthorpe, they had 60 million in the bank with no debt, and I was given share options, thousands, something like 50,000 share options. And every year I used to get share options from Alan, and they were all like £1.50, £1.80, things like that. And when I left, there were 3 pence. Not worth the paper they're written on.
Oh.
Not worth the paper they're written on.
That's a good way to end it, really.
Well, yeah, that's the way it normally happens, because you know the guy was Alan Cox was more interested in developing the bay. He was on the committee. He was on the board of the the bay. He was more interested in developing the bay than staying in the street, give up on it. And he was more interested in, and the other thing he was big on was he'd only employ, when this management developments, all had to do MBAs. We're all MBAs, all young kids MBAs. That's when we had the night along now. Yeah. 30% of every senior manager was gone in one day. And all the senior positions were given to these management development group, yeah, and there were a certain amount of expertise that were given extra responsibilities, and I was one of them. So I was given the company-wide responsibility for process control. But no, they won't listen, because it was made up of 13 to 18 companies. You go in, they don't want to listen, especially the Welsh. The Welsh one. Yeah, I've been banned from 2 of the plants, just for saying what I thought. They ask you what you think, you say what you thought. Not me, that. He's not coming here again. But I had to sign off. This is like, so then if they were doing anything, I had to sign it off. So they were all nicey after that. That's how I ended up in Cardiff.
Yeah.
Yeah. I was asked to go down to comment. They wanted my and what to do. So. And the shawl's Scunthorpe from under me.